Hello, this video is going to talk about finding the stretch factor and thus writing the equation of a parabola from a graph. And so if you have a graph, you're looking at these key points that you're looking for. And each of these we have the vertex labeled, so let's go, or indicated. Let's label those. This is 4, 2 is that vertex. The second one you have 2, 2. And then the last one you have negative 3, 4 as your vertex. Okay, so that means that you can write your equation in graphing form or vertex form. So you have y equals, you're going to have x, and you need that quantity squared. So I'm just going to write kind of our placeholders here for each of these equations because that's always going to be the case, where you have this quantity squared. And then from our work where we've been finding our graphing form, you know the x value of this first vertex is 4, so therefore it's going to be a minus 4 on the inside. The y value is 2 of our vertex, so that's going to be a plus 2 on the outside. For the second example, your coordinate is 2, 2, so they're the same, but since the first one's an x equals 2, that means you do minus 2 on the inside of the parentheses, and you do plus 2 on the outside of the parentheses. For the last one, your vertex is at negative 3, 4. So the x value is negative 3, so that means inside the parentheses you put x plus 3, and then you're just going to put a plus 4 on the outside. So for each of these, you did the opposite of the x value of the vertex inside your parentheses, and then you kept the y value of your vertex on the outside of the parentheses. That's the h and the k. The final piece is to include the stretch factor where possible or where appropriate. That's what it says up here. And there is a stretch factor in each of these. So the easiest thing to do, and you see you have a blue point indicated, from the vertex, if you move over 1 unit, however far up or down, that is the a value. So in this case, the blue dot is 2 units up, and so therefore your a value equals 2. And you just put that out in front where you see an a in your graphing or vertex form of the equation. And that's all you do for all these. So they're all indicated pretty nicely. If you move over 1 to the right from your vertex, however far up or down. So in this case, this goes 1, 2, 3, 4 down. So it's a negative 4. That negative is important. So that goes out in front of your parentheses. Same goes with this last one. If you move 1 to the right, however far up you go, 1, 2, 3, that is your stretch factor of a positive 3, and that goes out in front of the parentheses. And that's all there is to it when you have a graph indicated so nicely. Notice if you went left 1, you also go up 2 because of the symmetry. If you left 1, you'd go down 4. If you went left 1 for the last example, you'd go up 3. Now, with that said, you could do this algebraically. If you had y equals and you're trying to solve for a, and you had your x, if you didn't know that, x, I'm just choosing the middle one, x minus 2 quantity squared plus 2. If you knew this coordinate point of 3, negative 2, you could plug negative 2 in for y. You could plug 3 in for x and keep everything else the same. And then you could simplify and solve this equation. So that'd be negative 2 is equal to a times 1 squared plus 2. I'm going to have to move down a little bit here. As you keep on simplified, negative 2 equals a times 1, because that's 1 squared is. That's maybe a not necessary step, but that's what it is. And negative 2 equals a plus 2. And then you would subtract 2 on both sides, and a equals negative 4 that way. And so that's the same thing. And so you can do it algebraically with all this work. You know, if the point wasn't so nicely indicated. In this case, all of our examples, you are just going to be moving 1 to the right. But in other examples, you might have a point all over the place where it might be a little bit more work for you to find the a value, but you can always do it algebraically once you know the vertex.